Welcome back, students. So today we'll be continuing with the chapter 2 inverse trigonometric functions, and here we'll be dealing with the properties, right, related to the inverse trigonometric functions. So let us quickly begin. Now here we'll be talking about the very famous triangle method, where we can convert the trigonometric function. We can convert one trigonometric function into another, right? So how to convert trigonometric function into another function? So we'll be using the triangle method, right? So here sine inverse of x has been given to you. You treat this as x by 1. So here is a right angle triangle, right? So here you can see that here, treating this as an angle, what is the ratio of the sine? It is opposite side upon hypotenuse. So opposite side, I'm taking AB as x and hypotenuse as 1. So definitely by using the Pythagoras theorem, it becomes the side BC becomes under root of 1 minus x square. So you can use this triangle method to convert one trigonometric function into another. So sine inverse of x now will be written as cos inverse, right? Now what is the angle cos of the ratio? It is nothing but adjacent side upon hypotenuse. So it will be written as cos inverse under root 1 minus x square by 1. So that is cos inverse of under root 1 minus x square. How to write sine inverse of x in terms of tan inverse? So how to define tan ratio? It is nothing but the opposite side upon the adjacent side. So x upon under root 1 minus x square. So you can see tan inverse sine inverse of x is written as tan inverse of x upon under root 1 minus x square. Similarly, you can write that as sec inverse, right, which is nothing but the inverse of this, right? Cosec inverse you can apply here, right? So that becomes 1 by x. And cot inverse, it is nothing but under root sine inverse of x is cot inverse of under root 1 minus x square by x. So this becomes very handy when you solve the problems by the triangle method. It becomes very easy for you to convert one particular inverse trigonometric function into another. Similarly, you can go for cos inverse of x. So as you can see, right, it's a triangle, right? So you can treat x by 1. So I'm treating this as an angle C. With respect to that, let us define the cos. It is something but the adjacent side, x becomes the adjacent side, and this becomes the hypotenuse, right? So with respect to angle C, your cos angle is nothing but adjacent side upon hypotenuse, so x by 1. So again you can find AB by using Pythagoras theorem. So it will become under root of 1 minus x square. Now if you want to convert cos inverse of x into sine inverse, so obviously it is nothing but opposite side upon hypotenuse. So under root 1 minus x square by 1 is under root 1 minus x square. Now if you want to convert cos inverse of x into tan inverse, so look at the definition. It is nothing but the opposite side upon the adjacent side. So cos inverse of x can be written as tan inverse of under root 1 minus x square by x. Similarly, you can write the other inverse trigonometric ratio. Our basic thing is that how we are converting one inverse trigonometric function into another by the triangle method, right? Similarly, for tan inverse, you can write as this, right? I again consider right angle triangle ABC, where angle C, right, I'm treating this as the angle where you know that how tan ratio is defined. It's nothing but the opposite side upon adjacent side. So x by 1, here there is no 1, you have to understand it is 1, x by 1. So by Pythagoras theorem, this becomes under root of 1 plus x square. So how to write tan inverse in terms of sine inverse? So go by the definition, opposite side upon hypotenuse. So opposite side is x and hypotenuse is under root 1 plus x square. How to write tan inverse of x in terms of cos inverse? So adjacent side upon hypotenuse. So 1 by under root 1 plus x square. Similarly, you can go with the other trigonometric inverse trigonometric functions. Cosec inverse will be tan inverse of x can be nothing but written as cosec inverse under root of 1 plus x square by x. Tan inverse of x can be written as sec inverse of under root 1 plus x square by 1, which is nothing but under root 1 plus x square, and tan inverse of x is nothing but cot inverse of 1 by x, that is adjacent side upon the opposite side. So what I'm trying to tell you is that by triangle method you can convert easily one inverse trigonometric function in terms of the other 5 inverse trigonometric functions. Now we'll be dealing with the properties of inverse trigonometric functions one by one, which is very important, and you need to remember all this because we need to apply this while solving the problems. So you know that y equal to sine inverse of x, right? So if y equal to sine inverse of x, you can write x equal to sine y, and if x equal to sine y, that means y equal to sine inverse of x. So this is equivalent to sine of sine inverse of x, so this gets nullified, right? So it becomes x, where x is nothing but it belongs to the interval minus 1 1, and definitely it is different from sine inverse of sine x. Again it is the x, but x will belong to the interval minus pi by 2 because this talks about the value and this talks about the angle, right? So this is true for other 5 inverse trigonometric functions as well. So we can prove some properties of inverse trigonometric functions one by one, though this is not asked in the examination, but you need to remember. So by triangle method I told you how you can convert one inverse trigonometric function into another. So this is the direct way of telling you, and see here the thing is domain and range has been specified what you are supposed to take the value of x as. So sine inverse of 1 by x is nothing but cosec inverse of x, where x takes the value 1, or it can be greater than 1, it can be less than minus 1, or it can be equal to minus 1, right? So let us see how to prove this. So to prove this first result, right, we take cosec inverse of x as y, the RHS, right? Cosec inverse of x as y. The moment you take cosec inverse of x equal to y, so x becomes cosec y. Can you see that? So if I take the reciprocal, right, you know that reciprocal of x is 1 by x, and the reciprocal of cosec y is nothing but sine y, because sine y and cosec y are reciprocal of each other. So I have taken the reciprocal of this, right? So 1 by x equal to sine y. So sine shifted to that side, sine inverse of 1 by x will become y. But what is your y? Your y is nothing but cosec inverse of x. So that's how sine inverse of 1 by x is nothing but cosec inverse of x. You can prove the other way around also. Similarly, you can have cos inverse of 1 by x as sec inverse of x, or sec inverse of 1 by x as cos inverse of x, right? They mutually comply each other with the condition here, if I take cos inverse of 1 by x equal to sec inverse of x, x will be greater than 1, or at the max it can be equal to 1, or the value of x will be less than minus 1, or it can be equal to minus 1. Similarly, tan inverse of 1 by x is cot inverse of x for all x greater than 0, or I can say that cot inverse of 1 by x is tan inverse of x. Again, they are the complement, I mean they comply each other, right? So these two results can also be proved by the same method what we proved for showing sine inverse of 1 by x as cosec inverse of x, right? You can try for yourself. Second property, very important, what happens if x is negative? So sine inverse of minus x can be written as minus of sine inverse of x, where x belongs to the interval, closed interval minus 1 1. So let us prove that. You can take, let sine inverse of this minus x can be y, that means minus x becomes sine y, right? So I am shifting this negative side to that side, so x becomes minus sine y. So you know that minus of sine x is sine of minus x, that is the property that you studied in 11. So I am shifting this minus to y, so I can say that x equal to sine of minus y, right? Now if I shift this here, so sine inverse of x becomes minus y, right? So already you have taken y as sine inverse of minus x, right? So sine inverse of x equal to minus y, so minus as it is, and in place of y you are writing sine inverse of minus x. Hence sine inverse of minus x is nothing but this sign given to minus, it becomes minus of sine inverse of x. So you have to remember that sine inverse of negative x is nothing but minus of sine inverse of x. Similarly, you can prove tan inverse of minus x is minus of tan inverse of x, where x belongs to these are real numbers. Cosec inverse of minus x is negative cosec inverse of x for all mod of x greater than equal to 1. So this goes on pat with all these three. You have to remember for what values of minus x it becomes minus sign has to be written outside. It goes for sine inverse of minus x, it goes for tan inverse of minus x, and it goes for cosec inverse of minus x. For all these three, whenever you find that the x is negative, so while writing the answer, I mean the property, this minus sign will come outside and you have to write this as positive x, right? This negative will come outside. That is the way that you can remember. As far as the remaining three inverse trigonometric functions are concerned, let us have a quick look. Are they following the same strategy? As I told you, on the lines of sine inverse of minus x equal to minus sine inverse of x, you can prove these two, right? So you can have a try. Here look, cos inverse of minus x is not minus cos inverse of x, it is rather pi minus cos inverse of x. That is the difference, right? So here x belongs to the interval, close interval minus 1, 1. How to prove that? Again the same strategy. Let cos inverse of minus x be y, right? So this becomes minus x, shift this cos to that side, so it becomes cos y. So this shift this negative sign to this side, so x becomes minus cos y. Now in 11th standard you dealt with the formula minus of cos x is nothing but cos of pi minus x. So minus cos y will be written as cos of pi minus y. Therefore I can write cos inverse of x as nothing but pi minus y. Cos inverse of x can be written as pi minus y. Write pi as it is, minus as it is, but replace y by what you had taken. What you had taken? Y as cos inverse of minus x. Hence I can very well say that cos inverse of minus x is nothing but pi minus cos inverse of x. On the same lines you can say sec inverse of minus x is pi minus sec inverse of x for mod x greater than equal to 1, and cot inverse of minus x is pi minus cot inverse of x, x belongs to real number. So you have to remember that for sine inverse, for your tan inverse, right, the negative, you can write the negative outside, right? But for these three, that is cos inverse, sec inverse and cot inverse, you have to start with pi first. Pi minus cos inverse of x, pi minus sec inverse of x, pi minus cot inverse of x, right? Whereas for your sine inverse, cosec inverse and tan inverse, simply you have to replace by writing negative side before the property, before the the inverse trigonometric function. So this is the property that you need to remember. So the way this has been proved, you can prove these two on the same lines. Now the fourth property, the sum of sine inverse of x and cos inverse of x is always pi by 2, where x belongs to the interval minus 1, 1. How to prove? Let sine inverse of x be y. The moment I take sine inverse of x equal to y, that means x equal to sine y. So sine y can be written as cos pi by 2 minus y. They are the complement of each other. You did in your 11th standard, rather you did in your 10th standard also. Sine theta is cos 90 minus theta. 90 means pi by 2, right? So I am writing sine y as cos pi by 2 minus y. Therefore I can very well say that cos inverse of x, the moment, see, you just imagine this way, that x equal to cos of pi by 2 minus y. So shift this cos to that side. So cos inverse of x is, what are you left with? Pi by 2 minus y, right? So replace this y by sin inverse of x. That's what exactly I did. Cos inverse of x as it is, pi by 2 as it is, minus as it is, but in place of y you are writing sin inverse of x, which we have assumed. So shift. So what happens? This sin inverse minus sin inverse of x when shifted to that side. So cos inverse of x plus sin inverse of x is nothing but your pi by 2, right? On the same lines, you have the remaining two. Tan inverse of x plus cot inverse of x is pi by 2 for x belongs to real number, and cosec inverse of x plus sec inverse of x is again pi by 2 for all mod of x greater than equal to 1. So on the same lines, you can prove the way it is being proved. These two can also be proved, and you can check for yourself for the result. Next, fifth, there are three. You can see tan inverse of x plus tan inverse of y is tan inverse of x plus y upon 1 minus xy for if the product xy is less than 1. Then the same with the negative sign, right? Tan inverse of x minus tan inverse of y equal to tan inverse of x minus y upon 1 plus xy. You can see only there is a change in the sign, but this condition is used when there is negative sign in between. That is, the product xy is greater than minus 1, or sometimes depending if the product xy is greater than 1 and xy can be greater than 0, they are the positive numbers. So instead of writing tan inverse of x plus y upon 1 minus xy, you have to add an additional of pi plus. But this property is hardly used. Many a times it is seen that we will be dealing with these two properties. So to prove the very first one, what you can take, let tan inverse of x equal to theta, and tan inverse of y I am taking as phi. So x equal to tan theta, y equal to tan phi. So you know the very famous property that you did in your 11th standard, tan of a plus b. So here it is tan of theta plus phi. So it is tan theta plus tan phi upon 1 minus tan theta tan phi. So replace. What is your tan theta? Your tan theta is nothing but x. What is your tan phi? It is nothing but your y. So tan theta plus tan phi is x plus y. 1 upon 1 minus tan theta tan phi upon 1 minus xy. So if I need to find a value of theta plus phi, shift this tan to that side, so that becomes tan inverse of x plus y upon 1 minus xy. Then replace it by the original value. What was theta? Theta is nothing but your tan inverse of x. So theta is replaced by tan inverse of x, phi is replaced by tan inverse of phi, and this is how we get the result. In the same result, if you replace y by minus y, right, we get the second result, right? If we replace y by minus y, we get the second result, and replacing y by x, we get the third result. So this is how we do it. Here the formula is not asked, we need to only apply, right? Then comes the next, sixth property. 2 tan inverse of x is in terms of, we are writing in sin inverse. The same 2 tan inverse of x we are writing in terms of cos inverse. The same 2 tan inverse of x we are writing in terms of tan inverse, right? So our main task is to convert this 2 tan inverse of x into sin inverse, cos inverse and tan inverse. That is the primary inverse trigonometric function. So this is for the x mod of x less than equal to 1. This is for x greater than equal to 0, and x can lie between minus 1 and 1. So if you want to prove the first one, I can take tan inverse of x as y. The moment I take tan inverse of x as y, definitely x will become tan y. Now look at the right side, what I am supposed to prove. So I am taking the RHS first. So I will go the other way around. I am picking sin inverse of 2x, sin inverse of 2x upon 1 plus x square as sin inverse 2x. So this x, but what did you take as x? X is nothing but your tan y. So 2 tan y upon 1 plus x square. X square is nothing but tan square y. Now in 11th standard, you did one formula for the sine 2 theta. You had various formula for the sine you did for sine theta, half angle, sine 2 theta, sine 3 theta and all. So when you are converting sine in terms of time, you have this 2 tan theta upon 1 plus tan square theta. So 2 tan y upon 1 plus tan square y is nothing but the formula of sine 2y. So sine inverse and sine, they nullify. You are left with 2y. So 2 as it is, and replace y by tan inverse of x. That is your LHS. So So we started with this and ended up with this. So we can very well say that 2 tan inverse of x is nothing but sine inverse of 2x upon 1 plus x square. Similarly, you can go for the other thing. You can replace x by tan y, as you have already said. So 1 minus tan square y upon 1 plus tan square y is nothing but the formula of cos 2y. So cos inverse cos nullifies 2y, again replace y by tan inverse of x. So I can very well say that cos inverse of 1 minus x square upon 1 plus x square is nothing but 2 tan inverse of x. You can work out on the third property, so you will get the same answer. Now let us quickly use this in solving exercise 2.2, which is given on page 47. I will be solving a few problems to make you understand. The very first question, prove that 3 sine inverse of x is sine inverse of 3x minus 4x cube, where x belongs to the closed interval minus half half. Now by looking at this thing, right, this is a very familiar thing which you did know. So mark here that my job is to somehow convert this into the sign so that it gets nullified. So if I take the sine inverse of x as theta, right, I am taking sine inverse of x as theta. So what is happening? X will become sine theta, right? So I am starting with the RHS, right? There are various ways to do the same question which will give you the same answer. So here I am taking one of the option as sine inverse of x equal to theta. So x becomes sine theta. So I am starting with RHS and I will end up that it is equal to your LHS. So this is your RHS. So wherever x is there, I am replacing by sine theta. So 3 sine theta minus 4 sine cube theta is the very famous formula of sine 3 theta. So sine inverse and sine nullifies, you are left with 3 theta. So but what is your theta? It is nothing but sine inverse of x. Replace theta by sine inverse of x. So 3 sine inverse of x, which is nothing but your LHS. Okay. I am discussing question 4. Prove that 2 tan inverse of half plus 2 plus tan inverse of 1 by 7 is tan inverse of 31 by 17. Here everything is in terms of tan. So in such type of problems you can sometimes use, like, I mean, sometimes means what? I mean, depending upon what is to be proved, you can use triangle method also, right? But here it is no need, because everything what we need to prove is in terms of tan. Look at the final output, in what inverse trigonometric function you want it. So accordingly we will be, depending upon the situation, we will be solving it. So 2 tan inverse of half. So just now we discussed 2 tan inverse of x is nothing but tan inverse of 2x upon 1 minus 2x square. So the same thing here, x is nothing but my half. So I am applying 2 tan inverse of half. I am writing 2 tan inverse of half as tan inverse of 2 into half upon 1 minus half square. I am using the formula which we did. 2 tan inverse of x is nothing but tan inverse of 2x upon 1 minus x square. What is your x over here? I am taking x as half. And I am not doing anything with this tan inverse of 1 by 7. It is as it is. Only I am converting 2 tan inverse of x in terms of tan inverse of. Okay. So again I am repeating, 2 tan inverse of x is tan inverse of 2x upon 1 minus x square, where x is nothing but half. So you solve this. On solving, 2 gets cancelled, 1 minus 1 by 4. I'm taking the LCM, you get 1 upon 3 by 4. Now this 2 tan inverse of half is now reduced to tan inverse of 1 upon 3 by 4, which becomes 4 by 3 obviously in the next step. Now we are supposed to use the formula of tan inverse of x plus tan inverse of y. What is the formula of tan inverse of x plus tan inverse of y? Tan inverse of x plus y upon 1 minus xy. So your x is 4 by 3 and your y is 1 by 7. Put here, solve, you will get the answer over here. 28 plus 3 is 31, 21 minus 4 is 17. That is your RHS. Okay. Next, question 5. Write the function tan inverse of under root 1 plus x square minus 1 upon x, where x is not equal to 0, obviously, in the simplest form. When I say in the simplest form, means this particular stuff, under root 1 plus x square minus 1 upon x has to be converted in terms of tan function, because outside function it is a tan inverse. We know that tan inverse and tan gets nullified. So whenever it is in the simplest form, whichever inverse trigonometric function or trigonometric function is outside, its inverse or the trigonometric function has to be taken, so that inverse and that trigonometric function gets nullified and you are left with this stuff. So accordingly I have to choose the best substitution for x, so that I can convert this in terms of tan function. Why tan function? Because this is a tan inverse function. So I can take x as tan theta. The moment I take x as tan theta, so under root 1 plus tan square theta becomes sec square theta. Am I right? So you know that sec square theta and root will get cancelled. It will become sec theta minus 1, and obviously you have taken x as tan theta. Now you can simplify this further. Sec theta is nothing but 1 by cos theta minus 1. Tan theta can be written as sin theta by cos theta. So cos theta will get cancelled. So in the numerator you will be left with 1 minus cos theta upon sin theta. Now in the 11th standard you did 1 minus cos theta is nothing but 2 sin square theta by 2, half angle formula, and sin theta can be written as 2 sin theta by 2 cos theta by 2. 2 gets cancelled. 1 of the sin theta by 2 gets cancelled. So sin theta by 2 upon cos theta by 2 is your tan theta by 2, tan inverse and tan. That's the reason I told you have to substitute in such a way that it automatically gets transformed into tan function, so that tan inverse and tan gets cancelled. See, now this complete stuff has been transformed into tan theta by 2, so that this gets nullified. You are left with theta by 2, right? But what was your theta? Theta, if you have taken x equal to theta, so definitely theta will be tan inverse of x. So that's how the simplest form is nothing but half of tan inverse of x. Question 7. Again in the simplest form, tan inverse of under root 1 minus cos x upon 1 plus cos x, right? So again you have a direct formula. Again I need to convert this in the form of tan, so that this gets nullified, tan inverse, right? So 1 minus cos x can be written as 2 sin square x by 2. 1 plus cos x can be written as 2 cos square x by 2. Provided you remember the direct formula, otherwise you will keep haunting like how this has to crop up. So 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. When you are dealing with trigonometric functions or inverse trigonometric function, you need to know the basic formula. Without formula, we cannot move an inch, right? So 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2, right? 2 gets cancelled. Sin square x by 2 upon cos square x by 2 becomes tan square x by 2. That tan square x by 2 will get cancelled with this root, right? You are left with tan x by 2. So tan and tan inverse gets cancelled. You are left with x by 2. Let us discuss quickly question 8. Again in the simplest form, tan inverse of cos x minus sin x upon cos x plus sin x. Again I need to convert this stuff in the form of tan, so that tan inverse and tan gets nullified. So here what are we doing? We are dividing the numerator and denominator by cos x. So cos x upon cos x is 1 minus sin x upon cos x is tan x. Cos x upon cos x is 1 and sin x upon cos x is tan x. So I am dividing the numerator and denominator by cos x. So 1 can be written as tan pi by 4, tan x as it is, 1 as it is, and this 1 I am writing it as tan pi by 4. So you have a very famous formula, tan inverse of x minus y upon 1 plus xy. It is nothing but the formula of tan pi by 4 minus x. Tan, you remember the formula of tan a minus b, tan a minus tan b upon 1 plus tan a tan b. The same formula has been converted, right? This is being written in this form. Okay, tan a minus tan b upon 1 plus tan a tan b. Here your a is pi by 4 and b is your x. So I have converted this into the tan stuff. This will get nullified, and what are you left with? Pi by 4 minus x. That is the simplest form. Now question number 9 also. Write this function in the simplest form. So I have chosen x as a sin theta, okay, because again I need to convert this stuff into tan. So what I could feel the best thing is to take x as a sin theta. So a square is a square as it is, x square will become a square sin square theta. So by taking a square common, you are left with 1 minus sine square theta. But since a square is common and moreover root is there, so root of a square will become a, it will be shifted outside the root sign and you are left with 1 minus sine square theta. Now you know very well that 1 minus sine square theta is nothing but cos square theta, and root of cos square theta is nothing but your cos theta. So you are left with a sine theta upon a cos theta. A gets cancelled, sine theta by cos theta is nothing but your tan theta. Tan inverse tan nullifies, you are left with theta. But what did you initially take? You take x equal to a sine theta. So you can say that sine theta will be x by a, but I need to find the value of theta. So it will become sine inverse of x by a. This is how it has come. Question number 11. Find the value of tan inverse of 2 cos 2 sine inverse of half. So in such type of questions we proceed from the bracket, right? So the given function is tan inverse 2 cos 2 sine inverse of half. So you should know the value, accordingly we can work on this, right? So I am writing this as 2 cos 2 sine inverse. Now you know very well that sine inverse of half is nothing but pi by 6, correct? So it is very clear, tan inverse 2 cos 2 sine inverse, and your half is nothing but sine pi by 6. Sine 30 is your half. So in place of half I am writing sine pi by 6, so that this sine inverse and this sine gets nullified. You are left with 2 into pi by 6. So 2 and pi by 6 can be cancelled. 2 can cancel 6 3 times, right? So it is pi by 3. That I am showing in the next step. So you are left with tan inverse 2 cos, right, 2 into pi by 6. This sine inverse and sine has cancelled. So the next step I have shown 2 3s are 6. Now again, what is your cos pi by 3? You know that cos 60 is nothing but half. So this cos pi by 3, this 2 is as it is, can you see that? But cos pi by 3 is replaced by half. So 2 will get cancelled. You are left with tan inverse of 1. What angle of tan is 1? You know that it is 45. So tan inverse of 1 is 45. Now we cannot write 45 degree. We will be writing in terms of radians, that is pi by 4. Clear? Next is question number 12. Find the value of cot of tan inverse of a plus cot inverse of a. Just now we did the very famous property. Okay, if the angle is same, tan inverse of x plus cot inverse of x is pi by 2, right? So I can replace tan inverse of a plus cot inverse of a as pi by 2. So what is cot pi by 2? It is nothing but 0. See, I have written the reason why I am replacing tan inverse of a plus cot inverse of a as pi by 2, because tan inverse of x plus cot inverse of x is pi by 2. It should be same, x, here it is a, right? So this is how your cot of pi by 2 is 0. So the value of this is nothing but 0. Question 13. Find the value of tan half sine inverse of 2x upon 1 plus x square plus cos inverse of 1 minus y square upon 1 plus y square and so on, right? This is the range given to you. So we are supposed to find the value. So we'll do it one by one. So you know that tan half sine inverse of 2x plus cos inverse of 1 minus y square. So sine inverse of 2x upon 1 plus x square is nothing but 2 tan inverse of x. You did that. That is a property. And cos inverse of that is in terms of x. That's why it is 2 tan inverse of x. Okay, it is in terms of x. And cos inverse of, we did 1 minus x square upon 1 plus x square as 2 tan inverse of x. But as this function is in terms of y, so I will change this cos inverse of 1 minus y square upon 1 plus y square as 2 tan inverse of y. I have given the reason in the bracket, right? This is the property we did when I spoke about converting 2 tan inverse of x in terms of sine inverse, cos inverse and tan inverse. So that is that property I am using over here. So I can take 2 common easily outside the bracket. So that 2 and this 2 will definitely get cancelled. And I can apply the formula of tan inverse of x plus tan inverse of y. What is that formula? Tan inverse x plus y upon 1 minus xy. And this tan and this tan inverse will nullify each other. And I am left with x plus y upon 1 minus xy. Question 15. Tan inverse of x minus 1. If tan inverse of x minus 1 upon x minus 2 plus tan inverse of x plus 1 upon x plus 2 is pi by 4. Here you are solving the equation, right? Find the value of x. For what value of x this suits. So here we are see this x minus 1 upon x minus 2 to take as one complete unit, and x plus 1 upon x plus 2 you have to take it as a complete unit. So if by using this formula, tan inverse of x plus tan inverse of y as tan inverse of x plus y upon 1 minus xy, see I have applied the same formula. You treat x minus 1 upon x minus 2 as x and x plus 1 upon x plus 2 as y, and using this formula if you try to put it, so tan inverse of x plus y upon 1 minus xy, where x is this complete stuff and y is this complete stuff. So when you solve this, right, you are definitely x minus 1 into x plus 2 plus x plus 1 into x minus 2, this will go, right? You are supposed to take the LCM, right? And x minus 2 x plus 2, this denominators will get cancelled. You have to open the numerator and this will also denominator, right? And you know very well that this tan inverse is being shifted to that side. It has become tan pi by 4. Tan inverse has shifted to that side, so it has become tan by pi by 4 in the next step, and you know that tan 45 pi by 4 is nothing but 1. So this stuff gives the answer on solving as 2x square minus 4 upon minus 3 equal to 1. So on solving, minus 3 shifted to that side, minus 3, you solve 2x square minus 4 equal to minus 3. So 2x square equal to 4 minus 3, which is 1. So 2x square will be 1 by x square will be 1 by 2. So x will take both the values, plus 1 by root 2 and minus 1 by root 2. So these are the values of x, right? Next, question number 16. Find the value of sine inverse sine 2 pi by 3. You are supposed to keep in mind the principal value branch, right? Now don't say that okay, it's very simple, I will this sine inverse and sine are there, so I am going to nullify it, and the answer is 2 pi by 3. Now it would have been very nice if the answer would have been 2 pi by 3, right? But here to check whether 2 pi by 3 lies in this interval minus pi by 2 or not. If yes, then only then the answer is 2 pi by 3, otherwise not. Now definitely on nullifying this, 2 pi by 3 does not lie in this interval, right? So I need to make a change. How I am going to write sine 2 pi by 3? I am going to write this as sine of pi minus pi by 3. See, the meaning has not changed. Pi minus pi by 3 is 2 pi by 3 only. Now you did in your property of 11th standard, sine of pi minus x is sine x, right? So sine of pi minus pi by 3 will be sine pi by 3. Now sine inverse and sine will nullify each other. Now I am getting the result as pi by 3. Now ask yourself, is pi by 3 lying in this interval minus pi by 2, pi by 2? The answer is yes, a big yes. Hence the value of this is nothing but pi by 3. Don't say that the answer is 2 pi by 3 on nullifying this, because 2 pi by 3 does not lie in this interval. So we have to forcibly make to lie in this principal value branch, right? That is the technique. Some more formulae we'll discuss, which is very important, which you can use, though it is not directly given in your textbook, but still I would suggest that you can go for it. If you find these type of sums, you can definitely use, directly apply. The very first is sine inverse of x plus sine inverse of y. Here I am writing the keeping in view the domain and range as it is for the inverse trigonometric function. Here I have to report my answer in terms of sine inverse only, right? So sine inverse of x plus sine inverse of y equal to sine inverse of x under root 1 minus y square plus y under root 1 minus x square. It is the other way around. First you have to write x, take the square root 1 minus y square plus y under root 1 minus x square, right? So direct formula you can use, right? But how to prove this? The proof is not asked generally in the examination. This is just for your understanding. You can take sine inverse of x as some alpha, sine inverse of y equal to beta. So from this you will get x equal to sine a alpha and y equal to sine beta, right? Now you know the very famous formula, sine of alpha plus beta is nothing but sine alpha cos beta plus cos alpha sine beta, right? And this is how sine alpha plus beta, sine alpha is as it is, but cos beta can be written in terms of sine beta, because you have see whatever you have taken as the substitution, you have to change in that way only, because there is no direct way for cos beta, there is no way for sine. So that definitely I am changing this cos beta as under root 1 minus sine square beta, right? This sine beta is written as it is, but this cos alpha I am writing as under root of 1 minus sine square alpha, so that in my next step this sine alpha, right, is being changed as x. Can you see that sine alpha is being changed as x under root 1 minus sine square beta, as sine beta is y, so sine square beta will be y square, plus under root 1 as it is minus, what is your sine square alpha? You are saying that sine alpha is your x, so sine square alpha will be x square. And what is your sine beta? Sine beta is nothing but your y, so I am replacing sine beta by y. So just alpha plus beta will be, shift this sign to that side, it will become sine inverse of the whole thing. So this is how on rearranging you get sine inverse of x plus sine inverse of y, because alpha is your sine inverse of x, beta is your sine inverse of y, as you can see, sine inverse x under root 1 minus y square plus y under root 1 minus x square. Same thing follows for if in center there is minus. If here it is minus, same formula, only here the sign will change. You have to remember one thing, that if x is greater than 0, y is greater than 0 and x square plus y square is greater than 1, then sine inverse of x plus sine inverse of y may be an angle more than pi by 2, right? So sine inverse of x under root 1 minus y square, I am talking about this, is an angle between minus pi by 2 and pi by 2, right? Therefore sine inverse of x plus sine inverse of y can be written as pi minus this version. Now why this pi minus has come? Supposing this, see, this is the general thing for the general case, but in case if your x and y both are positive and the summation of x square, the sum of x square and y square is greater than 1, in that case you have to make some minor changes. You cannot write the answer as sine inverse of x and this, rather than before that you have to subtract it from pi, right? Because the angle is between minus pi by 2 and pi by 2. Let us see the example, how I have made use of this formula directly. Prove that sine inverse of x here you are being given that sine inverse of 3 by 5 and plus sine inverse of 8 by 17 equal to sine inverse of 77 by 85. So directly you can make use of that formula which I have taught you, sine inverse of x plus sine inverse of y, right? So can you see that I have applied this formula, sine inverse of x plus sine inverse of y is nothing but sine inverse of x under root 1 minus y square plus y under root 1 minus x square. Here x is 3 by 5 and y is 8 by 17. So quickly put in this formula, right? 3 by 5 under root of 1 minus 64 by 289, and this will go on, plus 8 by 17, 9 by 25, and then on solving your answer will be in terms of sine inverse. See, everything is in sine inverse, that's why I am directly using this formula. So it is on lines with this formula. Same version with negative. So same, nothing different. You have to take sine inverse of x as alpha, sine inverse of y equal to beta, and so on, which we did. Now but here we are using the formula of sine of alpha minus beta, sine alpha cos beta minus cos alpha sine beta, right? So here we are changing sine alpha as it is, but cos beta is written as 1 under root 1 minus sine square beta, cos sine beta as it is, but cos alpha is written as 1 minus sine square alpha. The reason behind that, it all depends upon what substitution you have taken. Your answer should be in terms of those substitution, right? So sine alpha minus beta is, sine alpha is written as x because sine alpha you have taken as x. Under root 1 minus sine beta you have taken as y, so sine square beta will become y square. Same what we did last time. 1 minus sine square alpha, if sine alpha is x, sine square alpha will become x square, and sine beta is being replaced by y. So shift this sign to that side, it becomes sine inverse, and here is the result with the same note. Now cos inverse of x plus cos inverse of y equal to cos inverse of xy minus, look here, in the center if it is plus, in the result will be negative, and in the center if it is negative, in the result it will be positive because of the cos of a plus b and cos of a minus b formula. So same technique we are going to use. So let us take cos inverse of x as alpha and cos inverse of y equal to beta. So cos your x will become cos alpha, your y will become cos beta, right? And here I am going to use the famous property cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So what I am doing, cos alpha cos beta, there is no problem because it is x and y, but I am changing this sin alpha as under root 1 minus cos square alpha and sin beta as under root 1 minus cos square beta, because you are supposed to change in the form of substitution that you have taken, because there is no substitution for sin alpha and sin beta over here. So you have to change according to the substitution. Now see, cos alpha is your x, cos beta is your y, it becomes xy minus under root 1 minus cos square alpha. If cos alpha is x, cos square alpha will become x square. Cos beta is y, so cos square beta will become y square. And therefore shift this cos to that side, it becomes cos inverse. And what was your alpha plus beta? Alpha plus beta is nothing but what? It is nothing but cos inverse of x and cos inverse of y. So cos inverse of x is your alpha, beta is your cos inverse of y, it is nothing but cos inverse of xy minus under root 1 minus x square under root 1 minus y square. Again the same procedure. If you find that this holds true, then writing, that means this will take the shape pi, you have to subtract it from pi. Don't write the answer as this, but in your NCERT thing you will hardly come across this. Will be generally treating this, right, for the given thing, because here we will not consider this note, I mean in the examination, because it is taken for granted that this is not applicable for this note where x and y both are positive and the sum of x square and y square is greater than 1. Otherwise you have to subtract the result from pi. Let us take a quick example to counter to use this. If cos inverse of x by a plus cos inverse of y by b equal to a, then prove that this type of thing, right? So what is your LHS? Cos inverse of x by a plus cos inverse of y by b, right? So this is your a, right? I am supposed to prove this, so I am using this formula cos inverse of x plus cos inverse of y equal to cos inverse of xy under root 1 minus x square under root 1 minus y square, whatever formula I taught you. So replace your x by x by a, replace your y by b. Okay, you have to understand that this x by a, you have to treat it for some time as x, think this for some time as y, as 1 unit. X by a as you treat as x 1 unit and y by b as y. When you apply the formula, right, so you will see that this cos inverse shifted to that side has become cos a. So what are you left with? Xy upon ab minus under root of 1 minus x square by a square and so on, under root of 1 minus. I have taken this root under one roof. I have taken I have shifted this cos a to that side, x upon xy by ab minus cos a, and I have shifted this minus stuff to that side. It has become positive, right? So in order to get rid of this square root, I have taken the square on both the sides. Then I applied the identity a minus b the whole square is a square minus 2ab plus b square equal to, then I have opened it, okay, 1 minus x square by a square into 1 minus y square by b square, right? So this is of the format x minus a into x minus b, right? And you will get the answer like this, right? On solving further, this you can shift this cos square a to that side, so that becomes 1 minus cos square a, whatever gets cancelled, whatever you can simplify, you can simplify it further, right? You will see that this stuff x square y square a square b square will get cancelled after cancelling. And see, in order to get sin square, it is very important that I should transform this cos square a to that side. So 1 minus cos square a becomes sin square a, and this is how we get the desired result. If cos square inverse of x plus cos inverse of y plus cos inverse of z equal to pi, then prove that cos square plus prove that x square plus y square plus z square plus 2xyz is 1. So what can we do? Cos inverse of x plus cos inverse of y, is written as it is. I'm shifting this cos inverse of z to that side, so that becomes pi minus cos inverse of z. So pi minus cos inverse of z is nothing but your cos inverse of minus z. Remember that property, right? Cos inverse of the negative angle is pi minus of cos inverse of the positive angle. So that property I have used here. So pi minus cos inverse of z is replaced as cos inverse of minus z. Here I am applying the property of cos inverse of x plus cos inverse of y, which is nothing but cos inverse xy minus under root 1 minus x square into 1 minus under root 1 minus y square, and so on. Shift, you will find that this cos inverse and cos inverse gets nullified on both the side, right? So you are left with xy, this stuff is left out, and minus z is left out. Then you bring everything to one side, xy minus z shifted to that side has become plus z, and this minus stuff when shifted to that side has become plus. Now you square both the sides to get rid of this square root sign. So when I square both the side, so xy plus z the whole square is x square y square plus z square plus 2xyz by using the identity of a plus b the whole square. And here I am opening it. 1 into 1 is 1, 1 minus y square minus x square plus x square y square. Then shift this to one side, you are left with 1 on the RHS, and that's what we needed to prove. The same thing with the negative version of cos inverse of x minus cos inverse of y. We'll get like this, cos, the same thing, but if you find minus in the center, in the formula this becomes plus. If it is plus, then it becomes minus, rest remains same. Same again, how to prove this? Cos inverse of x you can take as alpha, cos inverse of y you can take as beta. From this x equal to cos alpha, from this y equal to cos beta. Then you can use the formula of cos of alpha minus beta, cos alpha cos beta plus sin alpha sin beta. So cos shifted to that, so cos alpha minus beta is cos alpha cos beta, plus sin alpha is written as under root of 1 minus cos square alpha, and sin beta is written as under root 1 minus cos square beta. So why have changed? Because of the substitution. I want the answer in this form, right? Because there is no direct substitution for sin alpha and sin beta. Can you find? Is anything taken as sin alpha and sin beta? No. That's the reason I'm changing that, right? So now cos square alpha is x square, cos square beta is y square. So alpha minus beta, cos shifted to that side, cos square, cos inverse, and this way you get the formula. Again the same thing with the note that if x is greater than 0 and y is greater than 0, so if you come across this formula, and this is an exceptional case, you have to subtract it from pi. This stuff you are supposed to subtract it from pi. So with that we come to the end of today's session, right? I hope you got, there are so many properties to be followed and applied. So the moment you remember these properties and you look at the questions to be solved, it becomes when you can get an idea like which formula is apt to solve this inverse trigonometric function. Unless you remember the property, it becomes very difficult to solve. So my advice would be to whatever properties we have discussed today, right, write it down, and then you with the proper formula you remember, and then with the examples you try to solve.